to see a full-packed auditorium. Really, really awesome. So thank you everyone for being here, and thanks again to our amazing organizers and sponsors for this meetup. So really, really cool. So may the 4th be with you. My name is Hans Kristian. I work as a platform engineer, or potato as we call it, in this small company called NAV. Have you heard about NAV? Yeah. And I do have a very good colleague of mine, Jan Kåre, wave your arm. All right. I'm stealing all the credit, and then I have 30 more colleagues working on this platform team, and I'm hogging all of the credit, really. Yeah, so this is me. What I'm going to talk about. So I made these slides really on the night train. So very hot off the press. I'm really excited to see what's appearing in front of me here. So, but I'm talking about infrastructure today. So infrastructure at NAV. It's a small operations. So we do have some infrastructure. No, really, it's quite a lot. And I'm going to talk a little bit about infrastructure as code, and then a little bit more about infrastructure as software. Yeah, just obligatory mention, really why it's nice to work at NAV. Really good purpose and being able to contribute to society. You get a lot of freedom to really use your skills where they are needed. Excellent work environment. It's one of Norway's largest IT departments. And if you're interested, if you go to desombetyr.no, you'll find more awesome reasons for joining NAV. And we do a lot of open source and cloud native stuff. So really sort of high level overview. This is really where we started back in, what was it, 2016-ish, when we started our cloud native Kubernetes journey. It looked like this. We had actually prod and yeah, some call it dev or some call it non-prod. So, but really, we have 2 clusters. Then in 2019, we expanded and we moved to the cloud. So the label is a little bit off there, but really. But again, looked quite similar. Nothing major changed there, really. But yeah, really. But then it's sort of what we did there was that then we really got the opportunity to make dynamic stuff more than just sort of the applications, because that had sort of been the goal until then, to automate the application stuff. But when we moved out to public cloud, then we could really leverage the power of public cloud, which is APIs for all of the things, and being able to provision infrastructure more dynamically. And as you can see here, sort of we have few clusters that are really large, where the teams, they get their own namespaces, and in the public cloud environment, they get their own projects. That would be equivalent to an Azure subscription for those of you using Azure. We are using Google Kubernetes, GCP. So some stats of what we are talking about. So we have 204 teams that operate autonomously, meaning that they are responsible for what they build. So you build it, you run it, you break it, you fix it, type of mentality. We have close to 1,600 applications in these Kubernetes clusters. And really, you can actually sort of time it with 2 because we have sort of dev and prod. So you can see here that we have we have cloud storage, buckets, we have databases, we have Kafka topics. So this all sort of adds up. And really sort of, it's sort of like this careful balancing, using the force kind of situation in order to make it all spin the way it's supposed to be. So far, so good. It's yeah, I see some nods, I see some thumbs up, really great. Yeah, so really, we have sort of 2 types of infrastructure at NAV, not counting any manual configuration. Of course, there are none of those. as you all know, everything is automated. But at least for the automated part, we have two types of infrastructure. We have infrastructure as code, and we have infrastructure as software. So raise your hand. Have you heard about infrastructure as code? Oh, nice, nice. Have you heard about infrastructure as software? Yeah, a little lesser hands. But really, what we are talking about here is really, we have two types of infrastructure softwares. We have portals, which is really something with a web UI of some sort. And then we have operators, which is more or less the same, doesn't have an UI, it has an API. And really, you can sort of put the comparison thingy here, where we tried to sort of, when do we use what? Because we leverage infrastructure as code for what sort of organizational. So we only have one network. We have the network. We have some subnets, of course. But that's sort of like, in that scale, infrastructure as code is really great. We only have a few clusters. We only have this one gigantic network. And it's sort of slowish change rate. It doesn't really change that. We aren't going in and changing the infrastructure as code or ISE every time we need to do a deployment. That's not what we use it for. Then we have sort of portals. The scope there is things that are sort of team specific. We have 200 teams, so that's sort of ish okay. And really sort of that is something that the teams do themselves, and they generally only do it once, sort of creating a team. You only create your team one time. And then maybe you add some members, but really sort of these things that we actually used to have them as infrastructure as code, and we always got the feedback, oh, it's so unintuitive to go into the repo, and you see this obscure YAML thingy or JSON or whatever it is, and you need to add yourself in there, and sort of clunky because you only do it every full moon where the stars are aligned or something like that. So really sort of having a portal where it's sort of like you go here and you click the button or you type in your name and then you're done. And again, sort of the change rate there on a sort of grand scale, it's sort of medium. On an individual scale, it's sort of you do it once and then, oh, I don't need to do that anymore. But that's okay. And then we really have the operators, where the scope is sort of really application specific, and where there are changes daily. We have several thousand deployments a week. It's a really high change rate on our application sort of level. So at that point, that is where sort of the operators really shine. Because there's a sort of like going back to the infrastructure as code, and I'm a little bit critic here. And they are good and bad, as you can see. I've tried to highlight a few here. Sort of, it's of course this is Terraform, HCL. It's okay. It's really quick to set up. That's the really nice part. Sort of, if you need to create a subnet or a Kubernetes cluster or a database, it's really, really quick to set up. And it fits very, very nice for very simple things that are sort of like, oh, it looks like this. It's this square here, and that's how it should be. Where it doesn't really fit, and we have learned this really the hard way, having some Terraform code bases that become quite hard to maintain when they just accumulate. There's, of course, strategies. You can use modules, you can have different repos and so forth, but they scale to a certain point. That's my point. And then you have things like where your state is locked up and you need to manually go in and fix stuff and so forth. Really, for these complex cases, probably some case you would need some data migration going from one version of a database to another. It's not just simply changing the version number and then running. It doesn't really work that way. I would have loved if it did, but at some point it sort of stops scaling and you need something else. But we do have Terraform. we use a tool called Atlantis. Anyone familiar with Atlantis? Yeah, it's really great. So this sort of makes it a little bit more fun working with Terraform, and sort of reduces some problems, typically that you have multiple people trying to lock the state at the same time, so those sort of things. But really, you have your Terraform code base, your Git repo, you create awesome change, you do something, and then you create a pull request. And what Atlantis would do is it would go on and do what's called a plan, and for all of the different sort of environments that you have, and you get a list out there. You can then say that, oh, this is good. You can get your teammates to approve having the whole GitHub workflow. It works really, really nice. And then you can just type a comment, Atlantis apply, and then Atlantis will make sure that, okay, there isn't a lock, there isn't anyone else has done something in between. You're good to go, and it will give you the result. And for the most part, it works. And that isn't the fault of Atlantis, really, but it's just that there's no silver bullets, really. And then you can clean up afterwards. And it works reasonably fine, at least when sort of the changes are every now and then and not sort of all of the times, and you have a huge queue of things that are waiting to be merged and applied. Sort of step in the right direction is TerraTest. Anyone tried TerraTest? It's quite nice. You can use your favorite programming language, Go, of course, to write your test. But then you're sort of like, oh, I need to have sort of my mental model, HCL, Terraform, and then I need to have Go here, and sort of, it's again, it's a step in the right direction. And then you have Pulumi. Anyone using Pulumi? Oh, really? Yeah, I'm not surprised, really. Yeah, it's sort of, it's Terraform, just using your favorite programming language. Again, it can be Go, it should be Go. It can be TypeScript, it can be C#. I'm not sure if Java is supported, so sorry to disappoint any Java users in the room. Yeah, really, it's for certain parts, it's Terraform and infrastructure as code, really, really great. But in NAV, we generally use it for sort of the organizational level. So we have our tenants, we have sort of overreaching sort of policies, and our network and our Kubernetes cluster, and really they don't change that much. So you must unlearn what you have learned. So then sort of enters infrastructure as software, and yeah, no surprise. Sort of you start with an empty editor, really, a little bit scary, but really sort of when you think of it, at least for sort of the more dynamic part, sort of if you take away these things that never really change, it's sort of like if you try to change it, then your whole organization needs to be changed, which isn't really something you can do every day. Really, what you are left up with is really things that are quite dynamic in nature. They need to change shape, they need to change the number of them. There needs to be sort of a life cycle for them. And really, that's where software fits very, very nicely in, because this is sort of your chance, really, to create something that's running on its own, and making sure that, oh, I'm responsible for this thing here. It can be a database, it can be a service, it can be access policies, doesn't really matter. And all of these, and most likely you will use some kind of API or multiple of APIs. And these providers, they all have good, reasonably good SDKs that you can integrate it. It's not that you start sort of on bare grounds, and there's ample of frameworks and libraries and such that you can rely on. But really, it sort of gives you the whole ability to sort of say that, oh, I need to do a lot of stuff here. I'm not only doing one thing. There are sort of variations here, and I really don't know what the variations might be ahead of time, because in the end, you are sort of constrained with some limitation of the ISE tools, mainly that it sort of expects that this object, it should be like this. If you try to have too many variations, you end up with a very wonky HCL, or you end up with a lot of duplicated code. And then all programming languages, almost all, have reasonably good test stories and test frameworks to actually, because really, this is what software engineers has been doing for a better part of how many decades, and it's really been sort of perfected over the years. And sort of there's this whole sort of category behind sort of writing maintainable code. It's not easy, but definitely there are a lot of good resources in how to do that. So it's not, again, that you need to sort of invent all of the things. Writing maintainable code is possible, but you need to put some effort in it, and a good tool helps. But really, sort of this life cycle management, where sort of most infrastructure as code only sort of do the provisioning, a good infrastructure as software will do the continuous life cycle. You continue to make sure that this state not only try to sort of revert or reconcile, but actively sort of engage if there are certain errors or you need to mutate state and upgrade. That is something that you build in programmatically. And then you can sleep at night. That's a nice thing, because then during the day, you write your software, and the software does the life cycle, really. It wakes up whenever it needs to be woken up, and it does its thing, and hopefully you can sleep. So really, again, summing up more here, or trying to sort of, so we have portals. They typically have sort of a web user interface. Often they are team-centric, and they might use operators or APIs under the hood, or they definitely do. They're not sort of doing things magically on their own. Then you have the operators, typically a sort of Kubernetes construct. We are using Kubernetes, so they typically sort of, they expose the Kubernetes API, and I'll go a little bit more into detail there. And more app-centric, they can of course be anything you choose. They can be team-centric, but mostly or often what we use them for are things that are app-specific. And they can use, of course, other operators. They can use other APIs in order to do their work. Again, so repeating myself a little bit, we have portals to, for instance, where you can self-manage your team, or you can create an unleash feature toggling instance. It's something that you only do once, and then it's there. And for operators, for instance, your application, it might need multiple Kafka topics. At some point, it only needed 3, and then at the next day, maybe you have implemented a new one, and you need 4, and these things change very dynamically. Or we have operators that do ID-porten clients. So when you have a new application, it should have an ID-porten client. So you don't need to go in and manually create it and copy over something. That's no fun. An example for a portal that we have, again, this is how you manage your team at NAV. It used to be sort of a YAML file, a very, very long YAML file. Now you go in here, there's this visivig to create your team, and off you go. And sort of, oh, this sounds simple. Yeah, sort of, but it does a lot of things behind the cover here. It talks with Azure AD and creates a group in Azure Active Directory. It creates a team in GitHub. Those are linked. But this is the source of truth, by the way. So this will continuously reconcile and make sure that the members that you have in your team here, those are the ones that will be actually in the AD group. It creates a Google Cloud project. It creates a Google Cloud artifact registry. It sets up all of the permissions for the team to make sure that they can access their project. It sets up the Kubernetes namespace, and it sets up the deployment regime that makes sure that this team can now deploy to their namespace. So it does a lot of things here, and it continues to make sure that this is actually how it's supposed to do. So it has its state, it knows about all of the teams and the members, and you make sure that that is continuously that way in all of the other downstream systems. And really, that is what sort of these operators do. So for our Kubernetes operators, anyone familiar with Kubernetes operators? Some of you have you created one before? Ah, cool. So really, this isn't really anything new. There's nothing new under the sun, really. But sort of your operator, it sort of embodies the operational knowledge as code and software into something that's running and continuously running. So it really, in Kubernetes, it watches some object or objects, your custom objects, so you extend the Kubernetes vocabulary. So for those of you who know Kubernetes, you have pods and you have deployments and services and ingress. This makes it possible for you to make something completely new. So you can make a Kafka topic, or you can make a nice application, or you can make an idempotent client, whatever you want. So it watches those and make sure that if there are changes, I will reconcile, I will apply those changes, and vice versa. If the world doesn't match what I'm supposed to do, it will then apply back to the world. And then it reports back, so you can see, typically when you have done, if you've used kubectl, you can use kubectl describe, and then your thing that you want to describe. And at the bottom there's a status field. So operators reports back and says, oh, you're missing so-and-so, and this didn't work because this and this reason. And that's really sort of the simplicity of it. And this is how we have been building infrastructure for the past, I don't know how many years. But the very first operator that we made is this Nicerator. So it's our application manifest. It's in the very simplest form, it looks like this. And it will create a Kubernetes deployment, a Kubernetes service, a Kubernetes ingress, network policies, and a bunch of other stuff. Actually, I did a count, and we now have 12 operators that we have made. And we have them all public code on GitHub. And actually, we also sort of reached a milestone where we sort of reached over 2,000 public repositories on GitHub. So we are quite proud about our open source code, and we are sort of continuously trying to improve that, because most of it is open code, and some of these are sort of open source projects, mainly our operators. They can be used on their own. The rest is really sort of there to have a transparent government, and if you want to make a pull request to foreldrepengesøknad, you are able to do so. Pull requests are welcome, really. Again, I think this is just recapping, but under the hood here, we are using, so all of our operators, at least so far, are written in Go. And the reason for that is that Kubernetes itself is written in Go, a lot of the tooling around Go, Docker is written in Go, there's a lot of ecosystem, and it's a systems programming language, really, so it fits quite nicely. Rust is becoming more popular, so maybe at some point, maybe there will be a nice NAV operators written in Rust, who knows? But at the moment, you have quite a mature ecosystem around Go. You have the Kube Builder project, controller runtime, controller tools. You have a lot of libraries, a lot of sort of tools here to really get you started. I'm not going to go into all of that, but really, if you're interested in sort of writing your own Kubernetes operator, and I would encourage as many of you to try that, just as an exercise to learn more about Kubernetes internals. And you can go to the Kube Builder project, and there's a really nice book there that takes you all the steps that you need to create a new operator. And it's really straightforward at this point. So again, sort of trying to visualize it a little bit. These are two projects. The one is the Nicerator operator, and the other one is this console portal thingy, and you can see sort of it's a lot of things that goes on. It's just to visualize that there's a lot of complexity here, and there's a lot of tests as well. All of the red dots on the left-hand side, those are sort of smoke tests, or sort of here is sort of a YAML that sort of goes in, and this is the YAML that's expected to get out on the other side to make sure that those always, when we make changes, we know exactly what will change. And that's sort of the beauty here, is that we really have the whole power of the tooling and the programming language and all of these constructs that software engineers has perfected over so long time to do proper testing. So of course we do write our unit level tests. We have integration tests where we do mocking. We have end-to-end tests, typically spinning up maybe a Minikube instance in our CI/CD environment, and we install the operators, and we run some commands there and make sure that when you get this resource here, something else happens on the other side to make sure that it's working. And then, of course, we do have a sort of a canary rollout regime where the dev environments are rolled out first. We have things going on there all the time to make sure that those are stable before things are rolling out to our production environments. And really, no more training you require. Or practice make perfect. Yeah, that's really the slides I had. Infrastructure is hard. There's sort of no secret, no hiding that. But if you treat it as sort of a software engineering principle, and you really should, and regardless if you use infrastructure as code or you use Golang or JavaScript or regardless, you can and you should apply the same software engineering principle. There really isn't, and at least in NAV, there isn't really a difference when you develop infrastructure and when you develop any other service that is NAV. There's users, so my users are my developers. I need to check on them and make sure that their needs are met. And I go back and I have some requirements, I have some work to do, and I do the same method of working, write sort of code in the same way. I add tests, I have pull requests, I have peer reviews, and the deployment, etc., etc., etc. It's indistinguishable to how our application teams in NAV are doing their work. Of course, I develop infrastructure, and they develop sort of the NAV services that you might be familiar with. That's the main difference there, really. So I think we have time for questions. Really a plug to NDC Oslo. Christina is talking. We have 3 amazing talks from NAV. We have 1 workshop about supply chain security. We have a talk where we are talking about that we are building a platform for front-end developers. That's really cool. And we have modeling versus reality. So if you're going to NDC Oslo, I really suggest you should. Then be sure to come visit our talks, and github.com/nice. It's very nice. I love that. And these are my details, and I think we have time for questions if there are any questions. So, yeah.
Have you looked into some of the frameworks around creating operators, like Crossplane, for instance, and how they compare to writing the operators from scratch with an SDK?
Yeah. So we do have. I haven't been the one sort of particularly looked into Crossplane. It's a really, really interesting project. The main different sort of I would sort of rather see sort of Crossplane as an alternative to writing my own operator if I don't have to. The thing is that under the hood in our Google Cloud environment, we use a very similar tool. It's called the config connector. Does the same thing as Crossplane, except it's not open source, or I guess it's open source, but it's only for Google stuff, while Crossplane is for any type of cloud environment. So if we were multi-cloud operations, which we are not, we would probably use crossplane. And I know there is sort of an evaluation if we should use crossplane or not, but currently we are not using crossplane.
Yeah. I think both crossplane and config connector is using Terraform providers to interface with infrastructure, actually.
Yeah, that might very well be.
Yep.
It makes sense because it's when we config connector isn't sort of always behaving the way it should be.
Do you use any like GitHub's tools like Flux or Argo?
No, not sort of in that particular fashion. So we sort of, yeah, I know. So it's sort of an interesting. So we to a certain extent we sort of treat our Kubernetes clusters as sort of some sort of truth, and sort of in sort of some way our operators there do the continuous ongoing reconciliation, but not from a Git repository. We haven't really that was sort of the evaluations, whether using GitHubs or not, happened before my time at NAV, so I can't really speak to all of that. But the sort of the takeaway was that the user experience, at least at that point, wasn't really up for it. The flow that you built something and you committed it to a GitHub's repository, and then your workflow just ended and it said, oh, I've done my thing, but your application still crashed and the whole workflow there. I know that that's been improved upon a lot, but we haven't really found sort of the killer sort of use cases for revisiting that. We haven't really had any problems with the way that we do deployment. It's really, you have, and in some sort we do have sort of GitHub-ish, because our application deployments is really one file in the application repo. It says it's nice YAML, and it has all of the configuration for your app, and it's sent to the cluster. So it's not entirely, it's not using Flux or Argo, it's not entirely GitOps, but it's very close to GitOps. All of the configurations are there, and really, if something terrible would have happened, you just rerun your deployment, really. Again, there are benefits, definitely, to using GitHub's approach, but we haven't seen that would have outweigh the sort of how that would have had to change the workflow that we have today and which benefit it would have given us. Yeah. Stefan.
I just missed the mic. No. I always have asked the same question every time I see abstraction built on top of Kubernetes, so that's time it's for you. Do you track the amount of time that you spend working with developers to help them understanding something that you did abstract from them because of the operator you built yourself? For example, you mentioned that you were deploying network policy, you were deploying like service and ingress. What if they could have solved it themselves if it hasn't been abstract from them?
Yeah. A very good point. And there are certainly times where we need to explain things. In most cases, we have found sort of explaining our sort of way of doing it easier than sort of explaining 10 different Kubernetes resources that they otherwise would have had to know. It's important to also note that they still have the ability to interface with the Kubernetes API. So we don't require. It's an option to use the operator. I think all of the teams do. There might be sort of 1 or 2 exceptions, but generally they find that is much more convenient than making a Helm chart and understanding all of the details under the hood. But they do have our way our deployment works really is that you interface with the Kubernetes API via proxy, but really you can send any object. But again, most or all of them choose to send the nice application manifest, but they could have sent the deployment and ingress and etc. but they don't choose to do that. We haven't really advocated that. We don't really. We do advocate that. Use our operator. Then you don't need to sort of think about security policies, disabling root, dropping privileges, etc., which they would have sort of met Kyverno and had a really challenge. Oh, you forgot to set this obscure thingy here. It's something to do with the kernel that you really shouldn't really ever need. So we do have sort of quite good feedback that this saves up time but they can interface directly with Kubernetes. Often they do that in a debugging fashion, so they certainly know that there is a pod running there, and some of the constructs related to that. But again, sort of they certainly have possibilities to do it themselves. And if there's suddenly a much better way, I guess that the teams will move on to that eventually. But sort of having that abstraction, sort of it frees us up. Sort of we have gone from Istio to Linkerd as a service mesh, and that was sort of without our developers knowing, because that was sort of an implementation detail that our operator sort of set up without them really having to know any specifics there.
Have you ever needed to break the API of a custom resource and create a new API version?
I'm not that I'm aware of. So currently it's Alpha 3. So I guess there must have been Alpha 1 and 2 at some point. Again, before my time. We are sort of drawing up what should be the next version of the API. And that would be a major breaking change, and we are debating if we are thinking this in completely new terms. How should the API look like, and I guess more importantly, how should the migration path for our 1,600 application be? Yeah, a good point.
If I want to create my first operator, do you have any suggestion of what I should make?
What you should make?
Yeah, you have any ideas?
No, really, you should scratch your own itch. If you should really make something that this I feel sort of is a pain for me or my users or what have you, and then try to solve that really, because there's endless of possibilities really. It's just a glorified just an API, and sort of the joke is that it's sort of like you come for the pods, but you stay for the API. Pods in Kubernetes might disappear at some point, and nodes and whatever, they might all be serverless or whatever. But the API is a really solid one. It will definitely evolve, but that's where Kubernetes shines. It's the integration method you have with the Kubernetes API. And if it happens to run as a pod or as a serverless something or a WASM something, that's sort of implementation details. Yeah, cool. Find me afterwards. I'll stick around. Cool. Thanks for having me.